the next section, we are going to make a few introductory remarks about occupational exposure assessment strategies. As I have said before, the design of an exposure assessment strategy should be driven by the reason for obtaining the samples. What is the purpose? And there are two main purposes that we can think of. The first one is the routine monitoring of workers' exposures to chemicals in a workplace and comparing them to an occupational exposure limit. And so this is what I would call as risk management. So the whole idea is to obtain measurements to assess where the workers under the industrial hygienist's care are with respect to the exposure limit, and then the industrial hygienist can take the appropriate risk management measures. The second one is a risk assessment reason, and here the goal for obtaining measurements is to determine a relationship between the exposure and the health outcome in an occupational epidemiological study, which in turn could lead to the establishment of new exposure limits or new standards. So there is a risk management reason and a risk assessment reason. Exposures, as you can imagine, vary between workers. They vary over time and over season. They vary between shifts, a night shift versus a day shift, and they vary by location. So in the same workplace where everybody is doing the same job, as you move from one location to the other in this room, your exposures could be different. And so any sampling strategy needs to be effective in capturing this variability. At the same time, the strategy must be feasible and efficient in that it should not require a large number of measurements. And occupational hygienists, industrial hygienists, operate with very limited resources in most cases. And so we really cannot have large sample sizes that you might see in a research project. This is not a research project that the industrial hygienists are doing. They really want to protect the workers under their care while at the same time not spending too much money. There are two criteria that the industrial hygienists keep in mind. The first one is effectiveness. How effective are they at doing their primary job, which is to protect workers? And that means, can they correctly assess the workers' exposures and correctly provide exposure decisions? The second one is to minimize the number of measurements, so be effective, but also be efficient. And you can see how these two conditions can be at odds with each other, and there is a trade-off between these two criteria. Thus, you can be really effective, meaning you really understand the worker distribution, and you can always make the correct decision if you spend a lot of money and you take a lot of measurements. So you have a very large sample size. So you can be very effective, but that would not be very efficient. Conversely, you could be very efficient. In fact, you could make no measurements at all and spend no money and provide an exposure decision, but that exposure decision could be completely wrong, and therefore you would not be effective at all. So you can see there's a trade-off between effectiveness and efficiency, and the appropriate balance needs to be struck between these two competing criteria. Sample collection. While this course does not talk about the technology behind collecting personal samples, there are a variety of techniques for measuring airborne particles or airborne gases and vapors or biological samples and so on. None of this is going to be discussed in this course. This course focuses on what to do once we have those measurements. But we still can make a few remarks about the types of samples that we have collected. So the first kind, personal samples, are obtained from the breathing zone of the worker and are the most representative of the worker's exposures. In contrast, area samples are obtained from samplers at fixed locations in the workplace, and they may not correlate well with personal measurements because the workers are moving from one location to the other, whereas the area samplers are at one location, and they may not provide the best estimate of the worker's exposure. And in a lot of situations, the area samplers may not be at the place where the source of the contaminant is. where the contaminant is being generated. In fact, the workers are probably closer to that because they are, in fact, doing various tasks that generate the contaminants. They may be mixing two chemicals, for example, and some of that is becoming airborne. And so a personal sampler that is mounted on the body of the worker would capture that particular task's exposure, but an area sampler that is located at some, corner of the workplace or maybe in the middle of the workplace may not capture that. So in most situations, personal samplers measure higher concentrations than static area samplers. Exposure metric. It is very important to know the metric that has relevance to the biological effect of interest. Before we go out and take a measurement, we need to have decided, and we should have a very good idea of what we are going to measure. So, for example, when we are sampling airborne particles, we can measure one of several particle size-based samples. An inhalable fraction, as you may remember from other courses, samples all the particles that we breathe in through our nose or through our mouth. And so this would be an appropriate metric for particles that cause a health effect, no matter where they deposit in the respiratory tract. So, for example, for lead aerosol, the inhalable criterion would be appropriate. In contrast, if we are interested in a substance that causes effects only if it's deposited in the alveolar region, in the deep part of the respiratory tract, then we would look at the respirable fraction. So if coal dust causes a disease called as coal workers pneumoconiosis, and this happens because of dust deposited in the alveolar region of the lung. Therefore, we are not really interested in the particles that deposit in the throat or even in the upper portions of the lung. We are interested in only those particles that deposit in the alveolar region. And so only those smaller sizes of particles are of health relevance. So these are mass-based exposure metrics. You could also have other metrics for measuring airborne particles. So traditionally, for example, diesel exhaust aerosol has been based on the mass concentration. So what is the mass concentration of diesel exhaust that deposits in the alveolar region of the respiratory tract? More recently, other metrics have been proposed, even though they have not really been accepted universally. One hypothesis is that it's not the mass, but the number of particles that is more important to the health outcome. And yet another hypothesis is it's the surface area of these particles and not the mass that is of relevance to the health outcome for diesel exhaust particles. The same thing has been proposed for nanometer-sized particles as well, that it's the number of particles or maybe the surface area of particles that are of greater health relevance than the mass of these nanometer-sized particles. As we'll discuss a little bit later on in the course, the choice of the exposure metric also affects the classification of workers into similar exposure groups or SEGs.